Hi, welcome everyone. This is the second lesson video on elevation and depression. In this lesson video, we are going to look at the calculations involved in elevation and depression. I have the first question on the board. Two observers, Ike and Musa, 46 meters apart, observe a bird on a vertical pole from the same side of the bird. The angle of elevation of the bird from Ike and Musa's eye are 40 degrees and 48 degrees respectively. If both are on the same horizontal ground with the pole, illustrate the information in a diagram. Calculate correct one decimal place the height of the pole. To illustrate this question in a diagram, there is a first video on this topic which I titled Elevation and Depression Introduction. If you have not watched that video, please do so now. Watch that one first before this one. That video is a prerequisite for this one. To continue, we'll take this to be the vertical pole. Then the two observers, Ike and Musa. Ike is here, Musa is here. And the question says they are on the same horizontal ground. Both of them are on the same horizontal ground with the vertical pole. Then the angle of elevation from Ike to the bird on top of the pole. So the bird is here, B at the top of the pole, and then this is the foot of the pole. The horizontal ground is the normal for both Ike and Musa. So the angle of elevation is for Ike is 40 degrees, while that of Musa is 48 degrees. And the question says that both of them are 46 meters apart. So 46 meters here, that's the distance between Ike and Musa. Then between Musa and the foot of the pole, we are not given the measurement, so we can use X to represent that. The height of the vertical pole, which is BF. Now, that's the diagram. So the second part of it, the calculation. If you look at this diagram very well, you discover that there are two right angles triangles there. We have BIF and BMF. These are the two right angle triangles there. And both of them will help us in calculating the height of the vertical pole. So this side is the opposite side to both of them, while the IF is the adjacent. So we are going to use tan. Tan 40, considering the BIF, is equals to opposite, which is BF, over adjacent, which is 46 plus X. 46 plus X. That's the distance from I to F. Then, if you cross multiply, you will have BF equals to tan 40 multiplying 46 and the x. We'll call this equation 1. Then, let's consider the smaller triangle. For the smaller triangle, which is BMF, is still tan, so I'll write tan 48 is equals to opposite, which is BF, over the adjacent, which is x. If you cross multiply, you will have BF equals to x tan 48. We'll call this equation 2. The next thing we're going to do is to equate the two. We have BF first equation, we also have BF second equation. So I'm going to equate the two. And if we equate the two, you will now have tan 40 into 46 plus x is equal to x tan 48. You open this bracket. Opening it, we have 46 tan 40 plus x times this will give you x tan 40 equals to x tan 48. We have x this side, we have x this side. So the next thing is to collect like terms. So we have 46 tan 40 equals to x tan 48 minus this one will come over x tan 40. Good. The next thing is 46 tan 40 is equals to, you factor this, x is common, then tan 48 minus tan 40. Going further, using calculator to do the calculation, we'll have 46 times 40 will give us 38.5986 by 4 decimal places. Then 1048 is 1.1106 minus tan 40 is 0.8391 by 4 decimal places. If you continue, this will give you x bracket. If you do the subtraction, 0.2715. And then finally, x will now be equals to 38.5986 over 0.2715. If you do this calculation, it will give you 142.1680 by 4 decimal places. So this is our x, but that's not the height of the vertical pole. Now, we have two equations which can help us get the height of the vertical pole. Either of them can give you the final answer. Now, equation 2 appears simpler than equation 1. Let's use it to get our final answer. Now, writing it here, using equation 2, I will now write BF is equals to, our x is 142.1680 tan 48. If you use calculator and work that out, you will get equals to 157.8936 by 4 decimal places. Then the question says correct to 1 decimal place. That's for the final answer. And if you correct this to 1 decimal place, it will give you 157.9 meters. Now, that's the height of the vertical pole. Then there's something I want to point out in this diagram. In the question, we were not told between Ike and Musa who is closer to the vertical pole. And it's very important. Their position is very important. So anytime you have this type of situation, the one with the higher or the highest angle will come first. That is, it will be the one closer to the right angle here. So between 40 and 48, 48 degrees is bigger than 40. You place it closer because 90 is here. This is 90 degrees. As you are moving away from 90, you will meet 48 first before you meet 40. So that's why we'll have 40 here before we'll have 48 before we'll have 40. If you interchange the two, you will not get the same answer. If you put 48 here and put 40 here, that's wrong. So take note, anytime you have this, anytime you see this type of question in an exam where we have two angles of elevation or even depression, there are two right angles. Place the one that is the highest, place it closer to the right angle, and then the smaller one further away from the right angle. We are going to look at another example which will help us to understand what we have on the screen better. Question number 2 says, a boat is on the same horizontal level as the foot of a cliff. The angle of depression of the boat from the top of the cliff is 60 degrees. If the boat is 150 meters away from the foot of the cliff, find the height of the cliff correct to 3 significant figures. We'll take this to be the cliff and this to be the boat, dot, both of them on the same horizontal level. The question says the angle of depression, meaning that the observer is looking down and the observer is on top of the cliff. So the observer is looking down to the boat. So the boat is down here. This is the foot of the cliff. This is the top of the cliff. And every observer must have a normal, a straight horizontal line. Then the angle of depression is between the normal and the depression line, which is 60 degrees. The distance between the boat and the foot of the cliff is 150 meters. That's the diagram. To calculate the height of the cliff, the height is the opposite. Now, this angle that is outside, we need to bring it into the triangle, the right angle triangle. If we bring it in, here will now be 60 degrees. Alternate angles. Alternate angles are equal. Okay. The height of the cliff, which is TF, is opposite to this angle, while the distance, 150, is adjacent to this angle. With that, we are going to use tan to solve the question. tan 60 is equals to opposite TF over adjacent, which is 150. The next thing you do is you cross multiply. TF times 1 will give you TF is equals to 150 tan 60. If you use your calculator and do that, you will get 259.81 by 2 decimal places. But the question says we should correct to 3 significant figures. If you do that, the 3 significant figures of this number will have 260 meters. That's the height of the cliff. Question number 3 says, a man 1.6 meters tall, standing on top of a mountain 298.4 meters high, observes the angle of depression of 2 flying boats, D and C, to be 28 degrees and 34 degrees respectively. Calculate the distance between the boats. Correct to 1 decimal place. This is the mountain, the top of the mountain, and the foot of the mountain. It says a man 1.6 meters tall. This is the height of the man. Is on top of this. So we'll extend it a little bit. So from this is the man. MT is the height of the man, which is 1.6 meters. So that's the height of the man standing on top of the mountain. Then the height of the mountain, TF, is 298.4 meters. Then the 2 flying boats, this man is looking down. These are the 2 flying boats, D and C. The one with the highest degrees will be closer to the right angle. So this 34 will be closer to the right angle, while 28 will be further away. So 28 belongs to D, while 34 belongs to C. So C will be here and D will be here. So this man observes this flying boat C. Remember, all of them will be on the same horizontal ground. Now, this man, the observer, will have his normal. Now, the angle of depression, the 34 degrees, which is for C, will be between the normal and the depression line. So we'll have 34 degrees here. The same man observes another flying boat, D. The angle of depression is between the normal and the depression line, and that is 28 degrees. And it says, calculate the distance between the boats. So these are the boats, D, C. Let's use X to represent the distance between the 2 of them. Meanwhile, the question did not give us the distance between C and the foot of the mountain, F. We can represent it with letter Y. Now, we have two triangles on the board. This is the right angle here. The diagram is complete. The next thing is to calculate the distance between the two flying boats, D and C. Now, to do the calculation, first of all, we need to bring these angles into the triangles. Here is 28, here will be 28 degrees, alternate angles. Why 34 here, 34 also here, alternate angles. Fine. The next thing is, let's calculate the total height. That is the height of the man plus the height of the mountain. So MF is equals to 1.6 plus 298.4. That will give you 300 meters. So what it means is that from the height from that man till the foot of the mountain, we have 300 meters. That's the complete height. Before we go into finding the value of x, let's find the value of y. That is the smaller triangle. Let's find the value of y because we'll need it when we are looking for the value of x, which is the distance between the two flying boats. Considering the smaller right angle, this is the opposite side, while this is the adjacent. That means we'll use tan. So tan 34 is equals to opposite, which is 300, the complete height, over y. If you cross multiply, we'll have y tan 34 equals to 300. Then y will now be 300 over tan 34. If you use your calculator to press this, you will get 444.77 by 2 decimal places meters. So by 2 decimal places, that's what you get, 444.77. Then we can find x. And finding x, we will need the bigger right angle. So the bigger right angle triangle is MDF. The angle there is 28 degrees. This is the opposite, while this is the adjacent. So we're going to use tan again. We'll have tan 28 is equals to 300 over the adjacent, which is x plus 444.77. That's the value of y. If you cross multiply, you will have tan 28 into x plus 444.77 equals to 300. Okay. Now, if you open the bracket, it will be x tan 28 plus 444.77 tan 28 equals to 300. Now, it will give us x tan 28. If you press this on your calculator, you will get 236.49 equals to 300. The next thing is x times 28 is equals to, this will go over to the other side. It will be 300 minus 236.49. You continue, this will give you 63.51. Then x will now be 63.51 over 1028. If you punch this on your calculator, it will give you 119.44 in 2 decimal places. In 2 decimal places. But the question says correct to 1 decimal place. So 1 decimal place of that number, so x is equals to 119.4 meters. That is the final answer. So we can see that the diagram is there. Even though we are not asked to make any sketch, you need to make the sketch. Immediately you make the sketch, everything becomes clearer to you on what to do. This is the sketch. And then we calculated y first, and then we found x, which is the distance between the 2 flying boats. Thank you for joining me today in this lesson video. I hope you enjoyed the examples we used. Join me next time as we solve more questions in mathematics. Thank you and bye for now.